All right, good afternoon, everybody. How is everyone today?
Pretty good. Good.
That's good. All right, well, my plans for today are to talk about ODP 305, which was already turned in, or 304, talk about the current ODP, and then any questions on PA3, and then I want to go ahead and I want to talk about Eclipse, Window Builder Swing, and move into talking about some other aspects of Java, in particular something called class extensions, which is another standard theme in object-oriented languages. So any questions up front?
What do you mean by class extensions? Like inheritance or?
Yeah.
I gotcha. I was looking up for PA3 some of the. I'm trying to go through the manuals for Java.
Mm-hmm.
I tried looking at tree and binary tree, and it keeps saying it's an interface of other things.
Yeah, you don't get to use that anyway.
Oh, like traversal or nothing?
You got to make your own tree class. You can use print writer, scanner, string, and file, and the other ones that we've been using. But you've got to create your own tree class. And we ran through really quickly some sample code Tuesday for that. We'll go through that code again today for a binary search tree, different type of tree. But we'll see, a way to break the problem into a tree class and a node class, and see how those can interact with each other. And our goal there will be to let you do everything that you did in 222, everything you know about trees and working with trees. Let you just kind of do that in Java instead of C.
It was ODP 304 that was due yesterday, right?
I believe so. I think my notes are a little off.
So I was trying to do 305 on, I think it was Tuesday, and there's apparently an assess for it, but it assesses for 304. I wasn't sure if that ended up overwriting my 304 submission.
It probably would have. Yeah, there was not an assess for 305 until this morning, I believe, at 8:05.
Dang it.
And when you say assess, it should tell you up front. So let me just hop into here. So how do we assess this? Assess this thing states.java. So when you do this, there's a message up here in the front, the closest we can get to boldface. You're about to assess your code for, and it'll list the ODP and a little, 2 or 3 word synopsis of it. So that's if you're trying to do 305 and it says 304, just X out or Control C. Just don't do the G command, and it'll be good.
I think it overwrote it, so.
Let me take a look.
Oh, so you're saying it comes back 0 out of 10 because it's assessing the wrong one, kind of a thing?
So yeah, let's see. You got 10 out of 10 on 304, and then like 27 minutes later, you got 0 out of 10 because you were probably trying to do 305.
Yeah.
All right, so I'll just take those out of the logbook, so you're good for your last submission, which was 10 out of 10. Yeah.
Okay. Awesome. Thank you.
Yeah. So just go ahead and do 305 at some point. All right, so let's go back and look at 304 first. So 304 was a bit of a stateful program called add class, and it had an internal integer that would keep track of a running sum. And then there was a read method that would get an integer from the user, add it to the sum, and then a sum method that would return the current sum. And so here's a way to do that. So here's the add class constructor. I import the Java scanner, and the scanner and the running sum are declared outside of any method, so that they're available in all of these methods. The constructor zeroes out the running sum and opens the scanner on system in. And then the read method uses the scanner's next int and adds that to the running sum, and then the sum method just returns whatever the current running sum is.
So out of curiosity, so you don't have to put public for the constructor, you can just put add class?
I guess so. It's probably better to put public.
Okay.
The one difference is if you don't put public, I could put this in any file.java and it'll still compile. If I say it's public and it don't have it in an addClass.java, the compiler will throw an error. But since it's sitting in the directory, it finds it anyway. All right, does 304 make sense?
Yep.
All right.
Yep.
So I don't know if we talk about structs in Java. I mean, I do when I'm first introducing it and comparing and contrasting to C, but I don't think struct is actually a thing in Java. It's really classes and then objects, which are instances.
It has structs, and one of the things I notice is just kind of weird about these OO languages is like the differentiation between struct is always different in every language. Like in C++, it's the same as a class, but it defaults public. In C#, it can have all the same things as a class, but it's stored on the stack. And it exists in Java, but you can't do inheritance with it. You can't do constructors. It's stored on the stack. And in Rust, it is a class. There is no like actual class name. So
Interesting. Okay.
some languages don't have the keyword struct. They just have class, like Python.
Yeah, so Java, it says it has a record statement. But I didn't know you could actually do struct in Java. That's good to know. All right, so let's look at ODP 305. And so this is a more stateful program. You're still going to have a constructor. We're not dealing with standard in this one, so we're not doing a scanner. But your constructor is basically just going to zero out an internal variable. And so you don't really need a constructor. You could just make a variable that's, part of the class and just set it equal to 0 where you declare it. But there's 4 methods you're going to want to interact with this class. The first is result, which just returns the current value of that internal variable. Process, which will modify that internal variable by either adding or multiplying it by whatever argument you pass to process. And the default behavior is whatever you pass to process gets added to that internal variable. But if you call do_mul, it doesn't change that variable, but it sets things up so the next time you say process, it multiplies that variable by n. And after that, each time you call process, it multiplies that internal variable by n until you call doAdd. And when you call doAdd, nothing changes except a state variable, which says, hey, the next time you call process, add it to that internal variable. So it's one process method that can do 2 different things. And instead of telling process what to do, you change the state of the object by calling doAdd or do_mul, and process looks at that state and decides what to do. So as an example of using this, you could construct a state. Thank you. And if you say process 5, it'll add 5 to the initialized variable 0. Internal variable is 5. If you say process 7, the internal variable is 12. If I looked at s.result right now, it would return 12. If I say do_mul, that variable is still 12, but I'm in the multiplication state now, and if I process 3, it takes 12 times 3, the internal value is now 36. I can say go back to addition, process a 1, 36 plus 1 is 37. I can switch back to multiplication, process 10, 37 times 10 is 370. And now if I look at s.result, I should get back a 370. So it's just playing with this idea of state. Very similar to the idea of a state machine in Engineering 250. And as we move into PA4, which we'll be doing next week, we're going to be working more and more with kind of stateful programs where some action will happen, but the consequences of that action depend on things that have happened in the past. So we're going to be setting up flags and recording information about state and then acting based on those. So this is just a little a bit of an intro to that. I cannot spell thoroughly. All right, so questions about that?
Just to be clear, basically use something like maybe a Boolean flag to be able to say yes or no to whether or not it's math or multiplication.
Exactly. Oh, that's weird.
You know, programming's kind of cool with how many different ways you can do the same thing.
Yeah. It is, unless perhaps you're the way I was when I was a kid, which was I wanted to know the way to do something. And that's why I was horrible in art class, you know. And I think part of why I got pulled into programming so strongly was because it really kind of, you know, encouraged this idea of find a way to do this that makes sense to you and go do it. So yeah, I think that is pretty cool.
Where somebody can do something that makes sense to them in 300 lines, someone else can do it in 100, make just as much sense to them, and be just as efficient, but it, you know, does the same thing.
Yeah.
It's kind of cool.
Totally. This is
How
really...
many paradigms have been made?
This is really weird. I accidentally said CD // and PWD shows //. And if I just go to slash, or 3 slashes, or 4 slashes, it does what I expect. But if you go to // it actually shows you // as your current directory. I don't know what that's about. I don't know if that's a bug or a feature. Or a backdoor.
Always a feature.
Right? All right. So those are the ODPs. So 305 is due tomorrow morning at 8. And looks like we've got a handful of people who have done this already. I've got a feeling the Monday, Wednesday class doesn't do the ODPs until Tuesday, Thursday. Because there's almost none of them submitted right now, and then they'll all come in later tonight.
It's funny, I try to do them on Monday, Wednesday,
Mm-hmm.
to see if I can kind of grasp the concept, and if I have any questions, I'll wait till, you know, today or Tuesday to do but
Yeah.
It's been kind of fun trying to figure it out on my own.
Cool. Yeah, that's sort of the goal, so that's awesome.
You know when you like eat food too fast to enjoy it? I
Mm-hmm.
feel like that's me in this class.
Oh, really?
I'm gonna slow down.
The cool thing about programming, though, is if you like blow through the early stuff, there's always more stuff to eat later. Although I guess your appetite correlates to like how much time you have to spend on it.
It's funny, having done the advanced class first, this is really nice to get back to the basics and learn some of the concepts that I just kind of took for granted on the last
Okay,
one.
cool.
But
I have a quick question on 305 real quick.
Go for it.
When it comes to the constructor for this one, I'm noticing a lack of information here on the stuff. So I'm kind of curious, what kind of constructor are we needing?
I'm not sure you even need a constructor.
You don't.
So in the beginning of your class, you could say, you know, integer value equals 0, and really the only initialization you need is to make sure this thing is initialized to 0 when the class is constructed. If you do this, when the class is constructed with the default constructor, right, value will be set to 0. And if you don't write an explicit constructor, there's always a default one that basically just, you know, does the initialization, allocates memory if it's needed, and gives you back the object. So you probably don't need to create a constructor here.
Is there like a subclass constructor of some kind you can access or override in this language?
You could access the, say, the object constructor.
There is a class I have to use for work called declarative base in Python.
Hmm.
It's for an object relational manager with a database.
Interesting.
And as long as I inherit that thing's constructor will set up any and all default subclasses the way it should be.
Okay.
And there's like a subclass constructor you can tap into to do that.
Mm-hmm. Interesting. All right, cool. Other questions on ODP? Any lingering questions on PA2? So PA2, I think I've gotten all the ones I'm going to get, unless someone's using 4 slip days. But, you know, everything looked really good with that. But any lingering issues with PA2? All right, let's talk about PA3. What kinds of issues are you running into?
So I have a question about building the tree.
Mm-hmm.
So I think I watched your Wednesday class.
Okay.
Talk about passing in a scanner.
Mm-hmm.
How do you pass in a scanner to a method?
It's exactly the same as passing any other type of argument. So we're going to flesh this out a little bit, but we can have like a node read tree, and we can say this is going to take a scanner file in. And when I want to call this from, say, my main program, I would do, you know, scanner file in, and then I'd do my try catch block business. So make a new scanner off of the file from 20q.txt or whatever the file name is. And then if I want to ingest the tree, right, I could just say something like, you know, root equals read tree, and I just pass that scanner object. And it passes exactly like an integer or a string or anything else. All right, well, let's run through some pseudocode for the different parts of PA3, and ask questions if and when they come up. So let's see. Yeah, we'll definitely go through that too. If I happen to forget, remind me. All right, so let's look at our main program. And this is just pseudocode. Some of it will look like Java or C, but it's really just kind of high-level, human-readable code. So what does our main program do? Check for... Go ahead.
It should just be a loop on the actual game. And,
Yeah.
There should be some initialization, like setting up the class with the desired file you want to load the tree into, and then it contains all that information for you to play the game with.
Cool. All right, so let's check the command line and see if there's a file name specified. And if there is, we're going to use that as the database file. If there's not, we're going to use 20q.txt as the database file. So check for command line arg. Determine what the input file is. And then let's do something like, you know, root equals tree read. Did I call it tree read or read tree? I called it read tree. I'm going to switch it to tree read. So we'll tree read, you know, input file. And you're probably going to want to, you know, in here, create a file object from input file, pass that to a constructor for scanner, do that in a try catch block, and so on, and pass a scanner to tree read. But, you know, call your ingest method. So this is basically ingest a tree from the file. And this will probably hand back a root, right? The root of the tree, so a node or maybe a tree. And then basically, maybe, you know, if root is a tree, maybe my tree class has a play game method. And maybe this will return a Boolean telling me whether I won or lost the game. And so maybe if not, you know, play game, that means I lost the game. Play game should have adjusted the tree in memory, and so the tree, you know, sitting at root should be my new improved decision tree. And so now I could do something like, you know, tree right. And maybe I'll give this the name of the file I want to write into. And this does the pre-order traversal of my tree and dumps it back out into this file. And then I'm just going to sit here in a loop and play forever. Or maybe I'll ask the person at the bottom, do you want to play again? And if they say yes, I'll go back up to the top. But it's really just a few steps. It's some initial, you know, processing to decide what the file name is, and to construct the initial tree, and then play the game. If you lose and the tree's been updated, write the new tree into the file, and then go back, play the game again. And mostly we just sit here in this loop just playing the game. And I'm deliberately not telling you, you know, exactly which classes to make, which methods to put in those classes, where to call different methods from, what to pass, what to get back, and so on and so forth. You've got complete control over that. So I'm not going to take your classes and try to run them with my own main programs. Right? You're giving me a main program to play 20 questions. That's what I'm going to run, and that's what I'm going to use to grade your assignment. So you've got a lot of creative freedom here. And that's deliberate on my part, right? Because PA 4 and 5, you're going to be designing almost the entire game yourself and making all these decisions. So I want to move from, you know, very rigidly specifying these things in the earlier assignments to having you explore the design space and make these decisions.
So realistically, for this to work, we should have at least 3 classes, all right? One main, one tree, and one node.
Correct.
Okay. And then obviously how they interface is up to us,
Mm-hmm.
as long as it works. Okay.
Right. All right, let's talk about playing the game first, because that's what I've been suggesting you start with. Oh, sorry to hear that. All right, yeah, we're recording. We got audio and video, so we're good. I've been suggesting you work on playing the game before you work on ingest or updating the tree or writing it back out. So let's look at playing the game. And I don't know if you're going to make this, you know, a method that you pass the root of a tree to, or if this is going to be a method inside the tree class, or what. But, you know, somewhere this thing is going to have access to the root of the tree. And so we could do something like this. You know, say hello, introduce yourself. We're going to play 20 questions, etc., etc., right? It's nice if you ask the person to think of something and then hit enter before you ask them the first question. Because if your first question is, you know, is it pink and wingless, then they're going to, you know, change their guess. So, you know, some sort of whatever intro you want there. And then something like, you know, temp equals root. While temp is a question, ask the question. Right, so these nodes have, you know, a question or answer in them, and then they have yes and no children. So if temp is a question, ask the question, get user response.
So would you say a good idea would be to have an accessor method for the nodes for each section?
It's up to you. Since probably you're the only one who's going to be using these nodes, if you want to just reach in there and access the fields from outside, I'm okay with that. If you want to make setters and getters, I'm okay with that too.
Okay, and that's just going to be whatever dot, you know, whatever question or whatever you decide to put in there.
Mm-hmm.
Okay.
So ask the question that's in the node, get the answer from the user. If the answer is yes, then set temp equal to its yes child. If the answer is no, then set temp equal to its no child. And then go back up to the top of the loop. If they say something other than yes or no, don't just assume they said yes, or don't just assume they said no. Either ask them again to say yes or no, or something, right? So if they say yes, move to the yes child. If they say no, move to the no child. Come back up here. If that child is also a question, you'll ask the question, get an answer. If the answer is no, you'll move to that child's no side. And if that's another question, you'll ask the question. So you'll keep going through here until you exit the loop. And at that point, temp is an answer. So print the answer. Ask the user if you were correct. If you were, you're done, right? The computer won, and you can exit the play game method. And if this is, you know, inside a loop in your main method, you'll play the game again, or ask the user if they want to play again, or whatever. So if yes, then you're done. If the answer is not correct, well, for your first version of this, don't worry about it, right? If the answer is not correct, okay, sorry, you know. But just worry about this part. This is, you know, a big part of the whole assignment. And this gets you, you know, working with trees, working with nodes, working with the user interaction, setting up 2 scanners, one to read the file maybe and one to read the user's answers, and it keeps all of that stuff straight. And it lets you figure out what's going to be called from where, what are we going to pass, what are we going to send back, right? Without any of the details of ingesting the tree, writing the tree back, modifying the tree at the end. Can we make an assumption that when reading the file with questions and answers, the questions always come after a line with Q and answers always come after a line with A? Yes, that is exactly the specification for the file. So the file will have a Q colon or an A colon, and the next line will be the question or answer.
We assume they're capitals, or?
Yes, definitely.
Okay.
Mm-hmm. All right, so since we're here, let's talk about updating the tree. So we're playing the game. Here's the root node. Is it an animal? If no, then it's a rock. If yes, does it walk? If no, then it's a worm. I mean, worms walk, but you know, it's Thursday. If it is, then we'll say it's a cat. So you play the game. Are you thinking of an animal? Yes. Does it walk? Yes. Are you thinking of a cat? Answer is no. All right. So if we're doing our game loop here, right? This was the last value of temp. Right? Temp was this node right here. All right. So we do the following. We say, what were you thinking of? So the correct answer. What were you thinking of, and get the answer from the user. That's dog. What's a good question for which yes is a dog and no is a cat? So does it bark? All right, well, this node temp looks like this. It's a cat, it's an answer, and the yes and no children are null. Right, that's typical answer node. All right, we've got a correct answer and we've got a new question. So here's what we want to do. We want to create 2 new nodes. We want to create a new answer node that looks just like this. It's got cat, it's got, you know, this is an answer, and it has no children. And we want to create another one. Actually, I should have put this over here. So here's cat, it's an answer, and it's got no children. We make a second node with the correct answer, which is dog. And then in this last node that we were at, we change this from an answer node to a question node. We change the question to be what the new question is. Does it bark? And we change the yes child to point to this node and the no child to point to this node.
And real quick, because I know we went through this a little bit on Tuesday, but can we, if we call that left and right, you know, yes and no, left and right, can we access that by just saying temp.right equals and then temp.left equals?
Mm-hmm.
Okay.
Yeah, that should work.
But without the parentheses, right? Because we're accessing a field.
If you're accessing a field, yeah, no parentheses.
Okay.
Mm-hmm.
So you would have two temporaries then, basically, or I guess 3 temporaries. You'd have the new node, you'd have the old one, plus the temporary that you're gonna overwrite.
Mm-hmm. Yeah, I'd have the temporary I overwrote. I'd have a you know, new yes node equals new node, and a new no node equals new node. And then I'd set temp.yes equal to new yes node, temp.no equal to new node, temp.question equals new question, temp.type equals question. And then the next time you play the game, is an animal? Yes. Does it walk? Yes. When it gets down to temp, it's going to say, oh, that's a question. Does it bark? And then if you say yes, it'll say, oh, okay, it must be a dog.
So we're overwriting. We don't want to try to move anything. We want to just overwrite.
I wouldn't try to move anything, but you got two options. One is to create a completely new node and change what the previous node points to. And that's the way I've suggested people do it in the past, but I think you can probably do it, if you're careful, by just changing the fields in this last node that you get to. Just make sure you're very careful about it.
Yeah, I was thinking maybe do like node old equals new node, and then temp equal, or old equals temp, and then now temp equals the new question and all that stuff.
Yeah, so if you say node temp equals this node dot yes, you should be okay. But if you construct a new node and copy this thing's yes node into it, this won't work, because you'll be changing a different node.
Gotcha, okay. I'll just have to go through it a little careful.
All right, so that's the fix up that comes at the end of the game. So if you get to the end and you say, you know, were you thinking of such and such, and the user says no, right, you got to get a correct answer, get a new question, and then touch up your tree, change that last answer node into one more question node with the appropriate question, and have the yes and no point to the correct answer and the incorrect answer that you guessed.
Is there a specific step to overwrite the file, or it's going to automatically do that when you do those steps?
So this will not touch the file by itself. So if the answer was no, adjust the tree, and then write it by doing an NLR traversal back into the file. So you're going to have this file name that you determined, you know, in the very beginning, and after you ingest it, you're going to close it. And so at the end of playing the game, if you had to update the tree, make a change to the tree, then write that out using NLR traversal into the file. So do, you know, a pre-order traversal, but first open up a print writer to write into the file, and then pass that print writer object to your recursive traversal method. Instead of doing system.out.println that writes to your standard out, do, you know, print writer object.println to write into the file. And be really clear that, you know, we're never going to monkey with the file in a very detailed way. We're going to do two things with the file from the hard drive. We're going to ingest it in the very beginning of our program, right? Before we start playing, we're going to read it in. And then at the end of the game, if we've updated the tree, we're going to rewrite the entire file, start to finish, from the tree that we have in memory. And those are the only things we're going to do with the tree. We're never going to play the game by reading in lines from the file one at a time and asking questions from there, right? The only time we read the file is in the very beginning of this program when we build the first tree. And the only time we write the file, we're writing the entire file from start to finish by just traversing the entire tree. And if you try to do anything fancier than that, it's going to be a super duper headache, because the file is not really easy it's not really made for human consideration.
So would you say a good approach, obviously, use the tree class to like build it and have the methods for traversal, and then just use the main to call on those methods?
Yeah, that's probably a good way to do it. And keep in mind, a lot of the tree methods will actually be wrappers around node methods, which is that code we're going to go over again.
Yeah, it's gonna call on a lot of the stuff from the nodes in the tree class, which will all be kind of I guess implemented into the main program.
Yeah.
Okay.
All right. So writing. Writing the tree into a file, pretty similar to what we've done with tree traversals in the past. So open, you know, a print writer for writing to whatever the file name is. And then I'm just going to do, you know, root dot node left right, and I'll pass the print writer object to it. And if this is a method in my node class, right, then here's what my node left right method could look like. If left is not equal to null, then left dot NLR PW. This will use the left node's traversal method to write the entire left subtree into this file. And then pw.println. And we're going to print either a Q or an A, depending on whether this node, the root node, is a question or an answer. And then we're going to pw.println whatever the actual text of the question or answer is. And then we're going to traverse the right subtree, assuming it's not null, by calling the right subtree roots node left right method past the print writer. So it's like 4 lines of code. As our most recursive things with trees. The different feeling here from C is that, you know, we have to check to make sure left is not null before we call left's node left right. In our recursive traversal from 222, when we did this in C, we could just say, you know, NLR parentheses, you know, node arrow left. And inside NRL, we could say, hey, if the node you passed in is null, let's just return. But in this case, if left is null, we can't call left.nlr. That'll throw an exception. So we have to check in here to see if left is non-null. And if it is, then we can call that non-empty node, that existing node's traversal algorithm, and then print out the root data. I did this backwards, didn't I? Do the node first, and then do the left subtree, and then do the right subtree. Alright, is this good?
Yep.
So let's tackle the ingesting of the tree. So our file looks like, you know, Q colon blah, Q colon blah, A colon blah, Q colon blah, A colon blah, and who knows, right? No particular rhyme or reason that's immediately obvious to us, but it's a series of pairs of lines that constitute a question or an answer. And so our tree read is going to return probably a tree. But probably a node. I think this is another method you're going to need to write in the road class, in the node class. So tree read from a scanner, and this is going to return a node. The node it returns is the root of the tree that it builds by reading in from the scanner, right? By reading in from your file. And a single call to tree read may not read the entire file. So I have one scanner. I'm going to open it before I make my first call to tree read, which means my scanner's going to be sitting right here at the beginning of the file. And each time I call tree read, you know, my scanner is wherever it was after the last read from the scanner. And so if my file is sitting right here and I call tree read, I'm going to build a tree containing a single node. It's just going to be an answer node, right? And my scanner's internal memory pointer is going to move down to the next part of the input file. So this is one of these recursive things that it's good to think about sometimes to try to understand what's going on, but it's not necessary. And at some points, it will kind of drive you crazy to try to figure out. And at other points, it may feel like it's pretty clear, right? So don't be hamstrung by trying to make perfect sense out of this, right? You can code this and get it to work, even if it's a little bit hard to understand exactly how it does what it's doing. But the understanding will come as you work with it. So here's our tree read method. It takes in a scanner which has already been opened and it returns a node. So read a QA, which is going to be either a Q colon or an A colon, and then read a line of text. This is, from the scanner. So you call next line twice. Okay, if QA equals A colon, it means, you were at here in the file and you read the first line and it was A colon. So this text that you read was an answer. So, n equals new node. Make yourself a new node. N dot, if you're going to have a question answer flag, let's just suppose it's a question flag. N question equals false, because this is an answer. N dot text equals the text that you read in. And n dot yes equals n dot no equals null, because answer nodes don't have any children. And then we just return n. So if the current place that you are in the input file is pointing to an answer, tree read simply reads that answer node, that answer, the A colon and the next line which has the text, builds a single node and returns that. So it's just returning a leaf node. Otherwise, if the first line wasn't A colon, we can assume it's a Q colon. And so we'll do n equals a new node. N dot question here is going to be true. This is a question node. N dot text is going to be equal to whatever the second line was that you read, the text field. And now we do the recursive part. N dot yes equals tree read from the same scanner, and n dot no equals a second call to tree read from the same scanner, and then return n. So for a question node, you're going to basically reverse what happens when you do a pre-order traversal. You're going to read in the root node data from the file, and then you're going to read in the entire tree from that point in the file forward, and that's going to be the left child of this node. And then you're going to read in an entire tree from that point forward, and that's going to be the right child of this node.
Can you just keep calling next line, and it'll just keep the file pointer, or the position pointer?
Yeah. As long as you open the scanner once before you start all of this, and you keep passing that scanner object, whoever does next line, it'll be the next line from the file in this long succession of different instances of the method calling next line, but it's basically one file pointer. All right, does that seem doable?
Yep. Yeah, I think so.
Okay. I think those are the main pieces.
So in this, the scanner should run until there's no more next lines, right? Basically.
Yeah, if your file is written correctly, at the very end, the last time that you call tree read, you'll end up having read the last line of the file.
Okay. So there shouldn't have to be a while loop or any of that, right?
There shouldn't have to be a while loop. There shouldn't have to be, a try catch to see if there's nothing left in the file or anything like that. Because you can assume the file is correctly written, and this will sort of automatically work out precisely doing the right number of next lines.
Well, because ultimately it'll lead to null, right? And then recursively it should end up as one of them, yes, no, is null, right?
It should ultimately end up reading the very last line of the file. So say this is the end of the file. There should be one last tree read call that'll read in this, and then all of the recursion should unwind at that point, and you never actually end up reading beyond this last line.
Okay.
It just kind of magically works out because that's the way it was written.
And then, obviously this is a little more high level than exact, but as far as reading, is there, at that point, should we make like a string variable and make it equal to the next line kind of a deal for QA and for text? Is that?
Yeah, so string QA equals sc.nextline,
Yeah,
string
okay,
text equals sc.nextline, that kind of thing.
Okay, that's kind of what I was thinking. All right.
Yeah,
thank you.
cool.
I got it working first try. Awesome.
Nice. All right, so yeah, that's the main method. So the command line argument is just check. You got public static void main parentheses string bracket args. Just check args.length, and this is not length paren. This is just a field that you get with an array. Check this. If it's equal to 0, there's nothing on the command line, and so your input file is 20q.txt. If this is equal to 1, your input file is whatever is in args bracket 0. And if this is bigger than 1, the person put 2 or more things on the command line, that's a usage error. And you're welcome to just, say, hey, you can only put one thing on the command line, and you can just exit.
So try catch is not good in that situation.
Definitely not a try-catch situation, yeah.
Alright.
Okay. So yeah, get the input file, and then this is the tree read method, and then playing the game is going through here, and then adjusting the tree is all of this business, and then the node left right is writing back into the file is the node left right traversal. All right, so Tuesday we went through some sample code for doing a binary search tree of integers. And the purpose of that was to sort of show an example of how we might structure a set of classes, a main class that uses our tree class, a tree class that's our main interface to the tree, and then a node class that it turns out does most of the work. And so, using the tree in this case was just construct a tree, call the add method, call a print method. The tree class was the thing that we used to get a hold of the tree, right? It's the thing we pass to the constructor, so new tree. And then that tree object is what we use to get to the various methods for interacting with the tree. And this is probably similar to what you'll do in PA3 with your decision tree. But the methods in the tree class don't actually do a whole lot of work, right? For example, to add a node to the tree, mostly we're just going to call the root node's add method. So we're going to have an add method in the node class, and we're going to say, hey, root, you are a node, You're the root of a tree we want to add something to. I'm going to call your add method. And you go ahead and add this thing to the tree for me. Or, you know, to print a tree, we say, hey, root, you're the root of a tree that we want to print. I'm going to call your print method. And the one edge case we have to deal with in here is that sometimes our tree is empty, in which case root is null. And if root is null, we cannot say root.add. We cannot say root.print. That will not run our method. That will throw a null pointer exception. Because if root is null, there's no way to get to the print method. So for most of these methods in the tree class, we have a check to see if our tree is empty or some other edge case exists. And if it does, we do something special. For example, to add to an empty tree, we just make one node and we say that's the root of the tree. So we create a new node with the data value we want, n in this case, and we set root equal to that. In our print method, if our tree is empty, we don't have to do anything, so we just return. So some of the things in the tree class will just be wrappers around things in the node class. And then the node class looks very similar to what we did in 222 with trees. So for example, to add something to a tree, we say if the thing we're adding is smaller than the root value, right? Well, we're adding to a tree whose root is this node, right? This node that we're in here. And this node's data value is called data. So this used to say, you know, in C, if n is less than root arrow data. Well, we don't have to say root arrow because when we're running the add method, we're kind of inside the root node itself. And so we can just say data, and that means, you know, the data value at the root of the tree. So if n is less than data, we just want to say, hey, let's use the left child node's add method. And if the data we're adding is bigger than the root node's data, we're going to use the right subtree's root's add method. Right, so that node immediately on the right is the root of a binary tree, and we know we want to add to that tree because the value we're adding is bigger than our own value, and so we just say right.add. And it's just like when we said, you know, root.add, except in this case, you know, we want to add to the tree whose root is our right child or our left child. And then once more, there's the edge case, which is, hey, what if there is no left child? Well, we can't call the left child's add method if the left child is null. So if there's no left child, we don't need to recurse. We just create a new node and we say, hey, this is your left child. If we want to add to the right and there's currently nothing on the right, we simply create a new node and we say, okay, this is your right child. And we're done. And then printing, same thing. So this is an in-order traversal. And typically we would just say, you know, print the left subtree, print the root node data, print the right subtree. Edge cases, right, don't try to print the left subtree if there is no left subtree. So if left is not null, we'll call left.print. We'll print the root node data regardless. And then if right is not null, we'll call right.print. And so not exactly the class that you want for PA3, but similar in the sense of, you know, how you can split things between nodes and trees. And again, it's kind of up to you. So the method for ingesting from a file and building a tree, do you want that to be part of the node class or part of the tree class, or part of both classes and have the tree class call something in the node class? The method for writing a tree back into a file, should that be in the node class or the tree class, and so on. Up to you.
What about nesting classes?
You mean like defining a node class inside tree.java?
Yeah, like a private internal class. Well,
I'd-
not internal, but go ahead.
Yeah, I'd rather have each class in its own .java file.
Really?
Yeah, and stay away from inner classes for now.
Darn.
Hey, you know, more if you get paid by the file, it's a good thing.
That is true.
Out of curiosity, you have left and right are going to be part of your node, right, for this one?
For this one, not for PA3 though.
Oh, not for PA3.
PA3 we're going to use yes and no. Well, you can use whatever you want. I'm not going to tinker with your class. But everything we're doing sample code wise and stuff for PA3, we're calling the left child yes and the right child no.
Okay, but those are going to be, maybe I'm still thinking about this as C, because that's going to be like a pointer, right? Being that it's part of a tree.
It's sort of.
So what type are those going to be? Are they going to be strings?
They're going to be nodes.
Oh, okay, so it's going to be node left, node, or node yes, node no.
Yeah, so class node is going to have, you know, I don't know, maybe a Boolean to tell me if this is a question, maybe a string to store the text, and then it's going to have a node called yes and a node called no. And they kind of work like pointers, but we don't, you know, do anything in here to say this is a pointer. But that's effectively what happens, right? I like to wiggle around and say it's a reference to a node. But yeah, it's basically a pointer.
Okay, and so in a constructor, you're not really going to do anything with those because ultimately you're going to assign that in the main program when you're rewriting the file.
Right.
Basically.
But in the constructor, sometimes it's nice to just go ahead and set these to null.
So, just in case.
Yeah, just to sort of save you, you know, having to do this. And I think they end up null anyway with the default constructor, but it's nice to be explicit.
Okay.
I have trouble figuring out what variables I should be defining in the constructor as opposed to like just above the method or something.
So if you declare a variable above the constructor and outside of all the methods, it's kind of like a global inside the class. And that's a good thing to do if there's a variable that more than one method needs access to, or a variable that should persist outside of any of the methods. Right, so if there was something you were going to want to keep a value of, like the result, you know, in our ODPs, that should be, you know, defined outside of, you know, any of the methods. If you have a variable that's local to a method, like if you're doing your play the game and you have, you know, a temp pointer, this could be declared as just, you know, a local variable inside that method, and there'd be no reason to make it, you know, part of the entire class.
I had some where I had to remove them from the method so I could pass them along.
Oh, okay.
And I was trying to figure out if I should put them in the constructor or up at the top or above the method and stuff.
Right.
Yeah, that makes sense.
And if it makes sense to have something, you know, shared among different methods, go ahead and put it, you know, in here. Now, if temp was you know, a temporary node I was just using in here, and I declared it outside of all my methods, everything will still work. But it becomes a little more cluttered now because, you know, everywhere in my class, this thing still exists. I've kind of scoped it too broadly. And so you'd like to keep the scoping kind of as tight as necessary, but, you know, as loose as you need. And then where you actually give these things values, well, you know, I mean, I could, in my declaration of the class, I could say, you know, equals null, equals true. And, you know, if I just use the default constructor to make a node, well, this is going to be true, these will be null, right? I could even give this some initial value if I wanted. And by putting those in the declarations, that initialization happens when the node's constructed. But usually it's nice to write constructors and do specific things in there just to kind of like put it all in one place maybe. But it's kind of a style question, I guess.
I've seen lots of engineers that will, or a lot of the ones I know, complain if you put any kind of code in a constructor other than like an initialize function and separate your code that maybe would initialize the state of your class rather than the variables you pass into a constructor.
Right, right. Yeah, constructors, normally you're thinking initialization. At least in the code I've seen.
No style though.
Yeah, yeah. And you know, draw the window shades down. You can do whatever you want. You can even call them instantiators. All right. All right. Any other questions on kind of, you know, pseudocode level or more detailed PA3?
Just out of curiosity, so in this one, the node class is simply going to just initialize the nodes, right? And print the nodes as you need to, or should you print them from the tree class since the tree's going to encompass all of the nodes?
You're probably going to want a print method in the tree class, but it may end up punting to the print method in the node class. Like here, for example, right, where we had a print method you could get to from the tree, so you could say tree.print, but that really just calls the print method on the root node, and then that's the thing that actually recurses. The tricky thing is, you know, with recursion, if we're going to call a method blah as part of a tree, and we're going to recurse in there, it's got to continually be calling, you know, blah on a tree. And a tree, right, we have the root, which is actually a node. We have a left child, which is a node, a right child, which is a node. The way we structure a tree, it doesn't actually contain trees, it contains nodes. So the user wants to interact with the tree, but the tree is comprised of nodes, and the nodes want to recurse on other nodes. So that's why we tend to get this sort of, you know, splitting of functions into kind of the action part on the lower level, and then the interface part on the upper level. But you can do it different ways, and if there's a way that makes more sense, definitely go for it.
Okay.
All right, so let's do a 5-minute break. And when we come back, I want to talk about Eclipse and go through a kind of start to finish install on a VirtualBox of Eclipse, Java, Window Builder, and Swing, and kind of do a start to finish example of what you could do to get yourself ready for PA4 and PA5. We're going to start talking about PA4 next week, and that means we're going to be working in Eclipse. And so I want to make sure everybody can get the same environment with the same setup, same version numbers, and so on and so forth. So we'll talk about that after break, and we'll probably spend some time watching download meters run slowly. But let's come back in about 5 minutes, and then we'll jump into that. let's go through a kind of start to finish installation of everything you need for the rest of the course for PA4, PA5. And the main thing is we're going to do our code development with Eclipse. And I'm going to recommend 2022-03, which I think they call R. It's, I think, the latest version of Eclipse. Seems to work pretty well. We're going to use Java 11, and I'm going to insist we stick with Java 11. If you use something newer than that, it will not run when I try to run your code, and that'll be a problem. If you really want to use something older, you could, but it may not work as well as 11 does. And so we're going to stick with 11 in here. I don't have anything else going on right now, so I don't know why I'm cutting out. But if it gets really bad, let me know. We're going to stick with Java 11. And, cutting out bad. Interesting. No. Let me see if I got anything going on.
Kind of sounds like slow bandwidth or something like that, kind of cutting out.
Okay. Let me see what I got. Nothing much happening here. Let me try this. Let me close that. Let me turn off my screen. Turn it back on. Alright. Alright, well, the recording should at least have good audio, but if it keeps up, let me know, and maybe I'll reboot 3 times or something. So we're going to do Eclipse, we're going to do Java 11, and we're going to use Swing and Window Builder. And if you...
Individual packages, Swing and Window Builder?
They're basically like add-ons to Eclipse. Swing is a standard package of classes for doing graphical interfaces, basically making widgets. Window Builder is an add-on to Eclipse that lets you do drag and drop design using Swing classes, and it will save us from writing a bunch of code. If you don't have Eclipse installed on your machine right now, and if you're running under Linux, you can probably just download Eclipse and install it, and tell it to use Java 11 and be good with that. If you're running Windows, you could try putting in Eclipse, but you know, typically things work differently on Windows from Linux, and so you know, you could take a shot at it and see if it works for what you're doing or not. But, you know, we're going to talk about PA4 probably on Thursday, and that's not the time to start trying to install Eclipse in Java and Swing and Window Builder. You'd like to get this nailed down before then, preferably, you know, by Tuesday, so that as we start doing things in class, you can kind of play along and so on and so forth. So you can try this under Windows. OS X typically seems to have a lot of problems with this. Still cutting out bad. Dang. I'm not sure what to do about that. How's the audio? I mean, how's the video? Is that like pretty smooth? That's choppy too? Okay, so it is bandwidth.
Your recording's all local though, right?
Yeah, the recording should be fine because that's local. So you can always go back and catch that. Okay. So if you don't run Linux, or if you've already got a version of Eclipse installed and you don't want to roll it back and so on and so forth, your other option is to virtualize, right? Go ahead and do all of this in a virtual machine, and that's what I want to go through right now. And the newer PCs get the less capable they become in some ways, to where you have to do more and more workarounds to get a PC to do what you want it to do. And so I had a student in earlier. They've got an AMD machine, and their BIOS was preventing virtualization, and so they had to go in and change their BIOS settings. I've had Windows machines where you have to go in and turn off some hyper-threading option to get VirtualBox to run. So I'm going to go through an example here. I'm installing VirtualBox on top of Linux. If you try to do this and you get error messages, right, you might have to do some Googling and find some workarounds, and you're welcome to, you know, ask me for help, and we can screen share and so on. But let's do this with Linux. And so I've already downloaded and installed Dropbox. But, you know, download that in the usual way. Not Dropbox, VirtualBox. Alright, and so I'm going to start a new machine. So I'm going to say new, and I'm going to call this, you know, Thursday. I'm going to say under type that I want to run Linux, and version is going to be, I'm going to do Ubuntu 64-bit. And I'm going to say next, and give the machine some memory. If you've got at least 8 gig of memory, give yourself 4. More is better, but you know, if you've only got 4 gig, don't give yourself 4 gig to VirtualBox. Give yourself 2 or something. So I'll go with 4 gig. And then I'm mostly just going to take defaults. Just click through on the defaults, click through, and so now it's created a virtual machine. And I'm going to go ahead and say start. And it's going to ask what disk I want to boot from. All right. So I'm going to recommend Xubuntu just because it's relatively small. And so if you just do Xubuntu download, you can do version 18 or 20. I wouldn't mess with 24 just because it's kind of new. But 20 should be fine. 18 is also good. So Xubuntu version 18 or 20. These are called long-term support, but it's virtual, right? You're gonna use this and then toss it. So I've already downloaded the ISO, but you know, if I wanted to download this, I could go to United States and I could go right here, Xubuntu 20.04.4 desktop AMD.ISO. That would be the one I'd want. It's under 2 gig. Alright, so I broke this, so let me go ahead and find my ISO while I'm here. Xubuntu 20.04.4. So that would be the download file. All right. So so go ahead and browse to your ISO file. So I'll go with 20. Let's go ahead and do Xubuntu 20. We'll say choose, and then we'll go ahead and say start. Or not. I'm just going to ignore that error message. All right, so this is what you would see if you were installing Ubuntu on a physical machine. So if you were putting this, oh, thank you, on a an old laptop or something, you boot it up from the USB, which can be tricky to do sometimes because a lot of BIOSes don't want to boot from USBs anymore. So, you know, tweak the settings and hit escape and F5 and F2 when it's booting and so on. Get it to boot from the USB, and it'll bring you up to a screen like this. And if you're doing this on an actual machine, you probably want to try it first. Make sure the peripherals work, the wireless and so on. We're on a virtual machine. I'm just going to say install. And we're going to click through a few default options. So the keyboard layout should be fine. I'm going to take the default here, which says download updates while it's installing. And then it's going to want to talk about the file system. And again, this is a virtual machine, so it's a throwaway system, right? It's a completely imaginary PC. But if you were doing this on an actual machine, especially if you're dual booting, you want to be careful where you install this. You don't want to overwrite your current operating system unless that's what you really want to do. So I'm just going to go ahead and say erase the disk and install Xubuntu. And it'll give me another chance to confirm this. And I'll just say continue. And then it'll ask me for my time zone. And I'll go ahead with Los Angeles. And then it'll ask me to set up my first user account. So what's my name? My name's Nick, and it'll go ahead and use that for my username, and I'll just put in some super secret passwords. And I'm going to go ahead and say login automatically and say continue. And now it's going to sit here and it's going to run for a few minutes. And this will be super exciting to watch, not really. But we'll let this run in the background. Let me go ahead and go to my regular browser and show you what we're going to download. So I'm going to say Eclipse download. And make sure you do this through something reputable. So that when you find the first link which says Eclipse download, it's actually coming from eclipse.org, not, you know, cheapadvertisements.com, which will say, you know, download Eclipse here, and it'll, you know, throw some spam on your machine. We want the Eclipse installer. So this is important. If you use the installer, it will ask you what version of Java you want, and you can specify Java 11. If you just go ahead with Eclipse IDE, it will, I think, use your current version, or it will just use Java 17 or something. So we would go ahead and say Eclipse installer. And that'll do a download. And so we'll go from here. And this is a really pokey download. Takes a while. So this thing's still running. We got a few minutes. Let's just let it go. How's the audio? Is it any better, or is it still choppy?
It's a little bit better, but still a bit choppy at times.
Okay. I'm sorry about that. All right. So let's talk a little about Eclipse while we're waiting for this download to run. So Eclipse is an integrated development environment, an IDE, which is a fancy way of saying it's a software program that is a wrapper around a bunch of other programs. So if you've done Engineering 270, you've used an IDE called MPLab. And MPLab, you know, it has a window you can type your code into. It has a button you can say compile. It has a button you can click to run a debugger. It has a button you can click to load your program into the PIC chip. It may have a way to pull information out of your PIC chip. It may have a button for pulling up documentation. So an IDE takes all of these different behaviors and bundles them into a single program. And so Eclipse as an IDE will let us have a window where we can type Java code, but it's a window that knows about Java code. And if we make a typo, it will tell us. If we forget something, it will tell us. If we need to import a file, it will tell us. And it will help us write our code. If we use a linked list, it will say, hey, you need to define what a linked list is. And it'll actually give us an option. Should I import java.util.linkedList? And we can just click a button and it'll add the import statement for us. So IDEs are how most people write code because they kind of do the redundant parts for you. And, you know, how many times do you want to type public static void main parentheses string bracket bracket args? Close paren, right? And if you're working on a project, you don't want to spend your time and concentration typing stuff that, you know, could be typed by a machine. Well, so an IDE is that thing that will type it for you. I stay away from IDEs in the beginning of this course and in the other courses because they are counterproductive to learning. Right? If you're trying to learn classes and methods and things like that, you don't want something writing it for you. You want to be writing it yourself. But PA4 and PA5, we're going to be working with some really powerful packages of classes, and we're not going to want to be spending our time saying import this, import that, import this other thing. So we're going to leverage Eclipse and Window Builder, which is a plugin for Eclipse, to do a lot of the kind of redundant, mindless stuff for us. And then we can concentrate on the fun part, which is actually, you know, writing, coming up with algorithms and implementing them to do things like, you know, making a graphical game or things like that. Eclipse is a pretty old IDE. It's been around for a long time. A lot of the industry still uses it. A lot of products will come with a plugin so that you can use Eclipse to develop for their products. So I think I've mentioned I have a Garmin TriWatch, and it's programmable. And so you can write your own apps for it, your own watch faces and other apps. And the way you program that is through Eclipse. They have plugins you can install, and then it knows, you know, where the libraries are, how to push stuff over to the watch, pull stuff in, and so on and so forth. And so it's a good general purpose IDE to have under your belt. It's a good one to throw on your resume. But there's a ton of IDEs out there, and everybody makes their own IDE and adds their own features. And some people fall in love with them, and some people hate them, and you get into religious wars and all kinds of stuff. And it's kind of like editors, right? My suggestion is find an IDE that works for you and learn how to use it well. One of the problems, though, is that, you know, these things change. And if you don't mind, you know, relearning your tool every year, okay. But that can be a pain, too. So it's got upsides and downsides, but regardless, we're going to use Eclipse for PA4 and PA5 because it'll do the heavy lifting for us for swing. All right, we are chugging along here, just blinding speed. I'm going to get some liquid nitrogen to cool this down because I can see the smoke coming out of the internet cable.
Smoke back in.
Exactly. Alright, so once this is up, we're going to download, I'm going to do the Linux version of Eclipse Installer. And let me go ahead and I don't know how much I want to sneak ahead. I feel like it's going to be done in a minute.
So are we able to put this just straight on our desktop, or you want us to run it in like you want to?
No, if you can run it on your desktop, that's going to be easier.
Okay.
And it's a good thing to have available anyway. But if you don't have a Linux system, or if you've already got a version of Eclipse and you don't want to change it, or you know you're worried that having two versions of Eclipse will conflict or something, you can always throw it in a VirtualBox.
Okay.
So Android development used to be done in Eclipse. And that was horrible. That was so slow and kind of buggy. And then Android basically went to IntelliJ, and that seems to work better for the Android ecosystem. But IntelliJ is a really popular IDE. It can be kind of in your face. Like if you're not wearing the right color socks, it'll yell at you, you know. But it's super powerful and super flexible, and a lot of people swear by it. So that's another one that, you know, can be good to have on your resume. And you can kind of just you know, play around with them. And yeah, Kotlin, so Android used to just be Java. All Android development was done in Java, and now it's done, you know, kind of equally in Java and Kotlin. And the Android Studio usually gives you an option for which one you want to use. And a lot of the documentation pages you go to, there's a tab for Java and a tab for Kotlin. You can get, you know, segments of code in either language. I don't know if I'm pronouncing Kotlin right. But it's
Like it.
okay. All right, this is almost finished. Super exciting. What else can I tell you to make it sound like I planned this?
You may be able to import Kotlin libraries into Java code through Android Studio, if I remember correctly.
Okay.
I don't recall.
I'm hoping we have time at the end of this course to do at least one lecture on Android Studio. Because it's PA4 and PA5 are going to be fun, right? Because we're going to write a little bit of code and get a lot of bang for our buck. Android development is even more so, because you can go click, 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 and bingo, you've got, you know, like a game or you know, something that tells your horoscope or whatever, right? It's really, really rapid development. Once you get past, you know, 2,000 or 3,000 details that you have to figure out, and that change from week to week. But if I can, you know, get through those ahead of time, we can get into some pretty cool app development on Android in the space of one lecture. And it's just, you know, another version of object-oriented design, and it will look a lot like what we're doing with Swing. So Swing is this package of classes for creating windows, putting buttons on windows, interacting with pieces of a window, doing something when the person resizes the window or when they click on a button, things like that. And what we do with Swing for these next two assignments will feel a lot like what we do with Java or Kotlin when we do Android development, or what you'll do in a lot of other environments. If you do game development, if you write code in Unreal or Unity, right, it'll feel very similar. All right, installation is complete. You need to restart the computer. We say restart now. Guess what? It does not actually restart the computer. It takes you to a screen and it says remove the installation medium and press enter. And if you don't do that, it does nothing else. So press enter. Now it reboots.
Out of curiosity, is Unreal using C# as well?
I think it's C++.
C++. Ah, okay.
But I will say, if you want to learn C++, that's maybe the nicest spot to do it because it's garbage collected for you.
Cool. All right, so we've got a virtual machine up. I'm going to change the screen size because it defaults to 600 by 800, which was good in 1990, but not so good now. So I'm gonna go 1440 by 900, just so it fits. All right, and I'm going to download Eclipse. So I'm gonna go to my Firefox. And I'll download Eclipse installer. And we'll click on that right there. And again, make sure you're getting the installer rather than Eclipse IDE. And I think I tried this yesterday and it was really, really slow. So I might want to do a mirror. But let's try this. That looks a little pokey, so let me try a mirror while it's doing it. Let's see if this one looks faster. I lost my downloads. Yeah, I'm gonna kill this one. Alright, look at that, 44 kilobits per second. We got modem speeds here.
Better slow it down, you might be breaking some records.
I know.
You have the government knocking at your door.
Yep. They'll say, hey, you're running some kind of personal Netflix server, aren't you? Alright, well, we'll see if this speeds up in a minute. If it's going to take 30 minutes, obviously we're not going to wait for that. And I'll just punt to doing this on my actual system. But you know, meanwhile, so this is a whole virtual Linux machine, and you know, you can Control Alt T to run a terminal window, and you know, it's a whole Linux thing. And it's sitting on top of whatever system you installed this on. It's not replacing it. It's not rebooting. It's a completely virtual system. It's got virtual hard drives and process slots and so on. And if you go in the downloads area, you can see your download. So yeah, that's not going very fast. 26 minutes left. Okay, so I'll let that run, but I'm going to go ahead and run the Eclipse installer from my own desktop. So I'll download a .tar.gz file, and you know, if you download a file, blah.tar.gz, you can uncompress it by saying g-unzip blah.tar.gz. That leaves you with a blah.tar. And then you can extract that into your current directory by saying tar xvf blah.tar. So extract verbosely from the file blah.tar, and that'll unpack the archive into a directory tree rooted at your current directory. And that's what I did previously. And so it left me with this directory tree called Eclipse Installer, and it's got these files and directories in it. So eclipse-inst is executable, and I can run this, and it brings up a little splash screen for Eclipse Installer. And what you want is Eclipse IDE for Java developers. It should be the first thing. but we want Eclipse IDE for Java developers. We don't want the enterprise, we don't want C++, and so on and so forth. But, you know, mess around with these if you're curious. If you want to see how Eclipse works with some other environment, you know, you can play. But we're just going to do this first one, Eclipse IDE for Java developers. And then here's the really, really important step, right? We want to make sure we get Java 11. By default, this will say 17, I think. So go to the drop-down and pick Java 11. And I'm going with the OpenJDK as opposed to the proprietary one. And you can put it wherever you want. And I'm just going to go ahead and say install. Let's see how this is coming. Oh, it's almost a quarter of the way done. Alright, so that installs pretty quickly. You can go ahead and say launch. If you have desktop icons, it'll create a desktop icon for it. And then here's your splash screen, right? So this tells you Eclipse is doing its thing. And we come to this window which says, you know, select a directory as a workspace. So at the very least, you want a workspace for CSE223. And I don't know what other people do with workspaces. You could so when you develop things in Eclipse or in most IDEs, a lot of files get created for you. And typically, you know, you're going to have your .java files that you make. Those will get compiled into .class files. You might build Java archives, jar files from those. You might have documentation files that will go into their own directory tree. And you end up with a whole bunch of stuff related to your project. And you don't want that all kind of just sitting in one directory with the same files from all your other projects. So you like to put your stuff into separate directories. And you can use a workspace for that, but every time you change workspaces, all of your preferences get reset. It's a feature, I guess. So I usually, you know, when I'm teaching 223, I'll make one workspace for 223 in spring 2022, right? Rather than one per project, but you can experiment with it. So I'm just going to make a workspace. I'm just going to call this 223 Thursday. And I'm going to say use this as the default and do not ask again. Eclipse is really chatty. It likes talking to you, but usually there's options to say, you know, don't talk to me about that again. So it gets less chatty over time if you take advantage of those. Alright, so another look at the splash screen. And here's our Eclipse window. So not totally unlike MP Lab. There's some marketing on the front page here. We're just going to close out the welcome window. And I'm going to close out this window over here. But, you know, these are all tabbed. You can move these around. You can change, you know, how big each portion of your window is and all sorts of stuff like that. I'm just going to close this out. And I'm going to have basically a Package Explorer, which lets me look at my projects and the files in my projects. A main window where I'm going to edit my code. And down here is going to be where my output is. So when I run a program, the output will come here, but also error messages and things like that. Alright, so let's start a new Java project. Alright, so I'm going to come up here under File, and I'm going to say New Java Project. Alright, really important detail here. I'm going to pick a name. I don't know what we call this. Let's just call this, you know, weekend, because it's almost the weekend. Uncheck this box under module. It says create module info.java file. If you don't uncheck that, it starts getting really chatty with you and starts asking you all kinds of questions. We don't need this, so I'm going to uncheck that, and it'll stay unchecked. And I'm just going to do defaults for everything else. This should say Java 11 if that's what you used when you installed with the Eclipse installer. If you installed with 17, it'll say 17. You can try changing this back to 11. But you may want to just reinstall Eclipse. So I'm just going to go ahead and take the defaults, say finish, and bingo, I've got a new project started. So all of my projects are going to get listed over here. And there's this little triangle next to it, which basically tells me the project's open. If I right click and I say close project, that little triangle goes away. And I don't know if you can see, but the little folder looks like it's closed right now. If I double click, it'll open and it tells me, this project is open. So here's a handy little tip. Only have one project open at a time. We do this in MP Lab also. We do this with Verilog and Engineering 250. It's especially true with Eclipse. Only have one project open at a time. If I have 2 or 3 or 10 projects open and I say run, I'm never quite sure what it is that it's running. And I might have an editor window up here for main.java, and it might be main from a totally different project. And I change it, and I change it, and I change it, and nothing seems to help, because it's not the main.java that's being executed, right? So you can save yourself a lot of headache. Only have one project open at a time. Alright, so let's make a Java class. So I'm going to right-click, and I'm going to say new, and I'm going to say class. And here's a cool little dialog box. So package should be empty. We'll talk about packages later, but for now, your life will be more complex if you try to use packages. So I'm just going to leave the package blank. It's going to complain, but that's okay. So I'm going to pick a name for my Java class. I don't know. I'm going to call it main. Alright, it'll warn me, use of the default package is discouraged, don't worry about it. So here's a cool checkbox, public static void main. Would you like, which method stubs would you like to create? If I check this box, it'll write a main method for me. So I'm going to go ahead and do that. Everything else I'm going to leave in defaults. I'm going to say finish. And here's a class file for a class called main. It's public class main, and there's a public static void main, string bracket bracket args. If I want to run this, I can hit this green play button, that's the run, and it doesn't do much, right? So let's do a hello world. So I'm just going to go system.out.println hello. And if I run that, it'll ask me, do you want to save your resources before running? Yes, you can check this box. It'll always automatically save before you run. So I'll do that, and there's my hello. So I've got Java up on the air. Now, if I want, I can go into this workspace that I defined in the beginning of all of this, and I can see there's a project called weekend, which is a directory, and I've got 2 directories under there, bin and source. And if I look for all the files sitting here, under bin I've got main.class, under source I've got main.java, and then I've got some other files that are hidden that you do not want to tinker with. You don't want to change class path, project, or settings, because that'll break your Eclipse install. It's like the hidden files for Git. But if I look under source/main.java, that's my source file. And if I go into bin and I say Java main, that's not going to work because the version of Java that I have on my system right now is too old. I'm still running version 8. But if I had Java 11 installed on my machine, I could just say Java and main.class, and it would go ahead and run it. but it's telling me my Java version only goes up to version 52, and java.main is version 55. But we're going to do all of this from Eclipse. All right. So the editor window can be interesting. I'm going to type system, and as soon as I type system, it's grayed out. It's got a red underline under it, and there's a red X in a circle on the left, right? My editor is all kinds of freaked out right now. It's like, oh my gosh, you typed system, that's not valid, what are you doing, this is bad, things are going to go wrong, you know. It's watching as I type, and it's saying, well, that's a syntax error. You need to put a semicolon in, right? So you can pay attention to that, or you can ignore it. I've gotten to the point where I'm pretty good at ignoring everything that's coming out of the IDE while I'm typing. But if I say system and I hit a period, now it brings up a little pop-up window saying, do you mean system.class, system.error, system.in, system.out? What do you mean? What do you mean? And there's all these possibilities. Well, this is nice if I can't remember the name of a method, or I can't remember what type of arguments it takes, right? I've got kind of like instant documentation right here. But if I know what I'm going to type, I'm just going to keep typing system.out. And now, you know, it's giving me even more pop-up information over here on the right and telling me, you know, some details about system.out. And I'm going to ignore that, and I'm just going to say dot. And now here's all the things I could type after system.out dot. So I'm going to type print line. And I'm going to type an open parentheses, and it's going to type a closed parentheses for me, and it makes that red for some reason. And I'm just going to ignore that and type a quotation mark. And it's going to type a closing quotation mark, and it's going to complain there's no semicolon at the end. And if you haven't experienced this before, right, this can be really confusing because you're trying to type and it's typing for you, and it might not be trying to type the same thing you're trying to type. So I just ignore this, and I'm just going to say hello again. And I'm even going to type the closing quotation mark, and it's going to overwrite the one it did, and I'm going to type the closing parentheses, and it'll overwrite the one that it supplied, and I'll put in my semicolon. And then when I look up, you know, everything's great. There's no red squiggles and so on. And then I can go ahead and run this, and it says hello, hello again. All right. And, you know, in the public static void main, it created this comment with an intro of to do. And if you make a comment that begins with to do, you can go click, click, click and get a list of all the comments that begin with to do. And so you can leave yourself a task list of things that you still need to work on. And the tool will, you know, display those for you. This is basically Notepad. Right, so you move around with your cursor keys, and you move over with, you know, a tab or a space, and you delete by going backspace, and you go to a new line with enter and so on. It's Notepad, right? If you're comfortable using Notepad, you'll enjoy it. If you want something like VI, you can install a plugin called VWrapper, and it will give you VI functionality inside Eclipse. Otherwise, you're moving around with arrow keys and typing. So what else can I tell you about the IDE? So suppose I have a linked list, right? So I have a linked list called data. Well, linked list has a squiggly line underneath it. And if I put my mouse over that, it tells me linked list cannot be resolved to a type. And it's got 8 fixes available. And the first one says import linked list parentheses java.util. If I click that, it'll go ahead and write an import statement for me. So I don't have to remember where linked list comes from. And now linked list data is underlined in a squiggly yellow line. If I put my mouse over that, it says linked list is a raw type. References to a generic type linked list angle bracket E should be parameterized. 5 quick fixes. Add a type argument to linked list. Okay, if I click that, it'll go ahead, it'll put in my angle brackets and a question mark in the middle. And now I can just type the word, string. Oh yeah, I want a linked list of strings. And now it's happy. Well, data has still got a yellow underline underneath it. Why is that? The value of the local variable data is not used. 5 quick fixes available. Remove data, and so on and so forth. Well, I haven't written anything to do with data yet. But if I do, then that warning will go away. But if I meant to do something with data and I didn't, at the end I'll see this warning under here because it's underlined in yellow, and that might save me some time because it'll be like, oh yeah, I forgot to do anything with that linked list. So that's the kind of stuff that you get with an IDE. And yeah.
You got to talk about breakpoints, debugger windows.
We'll play around with debugging later.
Okay.
Briefly, if you go to Window, Perspective, Open Perspective, you can bring up a debug perspective, and it's mostly self-explanatory. You click over here to set a breakpoint, you can step and so on. But we'll go through that another time. This is all tabbed. If I create another class, it'll show up over here. I can switch between tabs. If I do a Control S, this asterisk will go away because it'll save my changes, and if I make changes, the asterisk shows up, and so on. So the usual, tabbed interface that you expect. So let's talk about Swing. So to install new software, we're going to go under Help, and we're going to say Install New Software. And you have to tell it where it should look for software. We're going to take the first option here, which is 2022-03. This is usually what we want. For some outside things like VWrapper, if you go to the website, it'll tell you what site to specify here. But we'll just go with eclipse.org releases 2022-03. And then here, where it says type filter text, I'm going to type Swing. And I get Swing Designer and Swing Designer documentation. I'll click that text box. I'll say next. And I'll say next. And I'll accept the license terms. And I'll say finish. And this progress bar or this progress message will slowly change from 48 to 53 to 80 something, and then it'll finish. And that's the only thing that tells you that anything is happening right now. So look down there for progress. And it's usually pretty quick. Pretty quick. Usually pretty quick. Okay, there we go. And then you have to restart, because, I don't know, that's what software does. And so this will give us all of the packages related to creating GUIs and so on. And then we're going to have to do one more install. So we're going to go under Help, Install New Software. We'll pick the same site as before. And then under Filter Text, I'm going to say Window Builder. And I'm just going to select all of those and say Next. And say Next. And accept the license terms, which are on the left now. And say Finish. And go 49% and then 83. And the good part is this is all like one time. If you're doing VirtualBox, that's a one-time setup. If you're installing Eclipse, that's a one-time. Installing these two pieces of software, that's a one-time operation until you move to a new version. So we only have to go through this once, restart one more time, and then we should be up on the air. I'm going to close this window out. And we got 5 minutes. Let's make a few GUIs in our last 5 minutes here. So I'm going to close this window. There's my weekend package. I'm going to close this. Alright, so let's create a Java program that just shows us a window. So I'm going to say File, and I'm going to say New, and instead of saying Java Project, I'm going to say Other. And I'm going to scroll down to Window Builder and expand that. And I'm going to scroll down to Swing Designer, and I'm going to scroll down to JFrame. And it's going to ask me for a project, and I'm going to call this, you know, Cool Stuff 1. Project weekend must be accessible. I think I messed up. I'm going to do File, New Java Project. And I'll call it Cool Stuff. Alright, but then inside here, instead of saying File, New Class, I'm going to say File, New Other, Window Builder, Swing Designer, and I'm going to create a JFrame. And it's going to ask me for a name. I'm going to call this Mainframe. And I'm just going to say Finish. And magically, I've got a ton of code now that's been written for me. There's a package, there's an import, here's a class declaration, here's a public static void main, here's some stuff in italics, here's some weird looking comments, and here's some methods being called. Right? I didn't write any of this. This got written for me by Window Builder. But all of this Java code, if I go ahead and run it, will create a window that, you know, I can move around and I can resize and I can click in and so on and so forth. And you can tell my program's running because my little run square is red. And if I close out this window, right, that goes back to gray and it tells me that mainframe was terminated. All right, so that's enough to have, you know, a window pop up. And then down here, there's a pair of tabs. There's a source tab and a design tab. If I click on the design tab, that takes me into a drag and drop interface where I can customize this window. So for example, I can say I want an absolute layout manager, which just means I want things to stay where I put them. I can put a button over here, and I can change the name of my button to, you know, hello. And if I run this, I've got a window with a button called hello, and I can click it. And if I go back to the source tab, I can see I've got more code in here now, including a constructor of something called a J button with an argument of hello, and then something called set bounds that basically says how big the button is and where it should be, and then it adds it to something called a content pane and so on. And a lot of the coding that we're going to do is going to be done through this drag and drop. And if I want something to happen, for example, when I click this button, I can just double click it here, and I'll end up in a section of code in here called public void action performed. And this method will be called when that button is clicked. So here I can say something like, you know, system.out.println hello to you too. And now if I run this, I've got my window. It's got a hello button. And if I click this, my output window will print a message, hello to you too. So it's going to be really easy to design graphical objects, right, using this design tab and just moving things around. And it's going to be really easy to tie actions on these objects to pieces of code that we want to have execute. And so next week we'll talk about some of the mechanisms that make all of this possible. So we'll talk about class extensions, and we'll look at some of these classes like a JFrame and so on and so forth. And then we'll go ahead and we'll start very carefully developing some graphics applications and learning some techniques for working with some of these visual elements. And then Thursday we'll probably talk about PA4, which will be a graphics-based game, and then we'll go from there.
A quick question: where did you download the window builder again?
So under Help, go to Install New Software, And then under select site, pick that first one, 2022-03. And then under type filter text, just do window builder, one word, no spaces. And if you don't hide items already installed, that should bring up your options. So all of these. Yep. All right, we're out of time. I don't know if my download ever finished over here or not. Hey, it looks like it finished. All right,
My
so.
eclipse stall hung, so.
Ah, fun. All right, that's all we got time for today. So if I don't see you in office hours tomorrow morning, have a fantastic rest of the week, great weekend, and I will see you on Tuesday. All right, take care.
Thanks, everyone.
You too.
Have a great weekend.
Thanks, you too.